Hello class. Today is part 8 of our curriculum review, and today we're going to be talking about direct variation. So let's find out what it means. Direct variation is nothing but a relationship between two variables in which one is a constant multiple of the other. In particular, when one variable changes, the other changes in proportion to the first. So when we look at our formula chart, we've got two formulas that we're focusing on in this particular concept. You'll notice here we have the slope-intercept form, which is y equals mx plus b, which is what we're used to, where the m is our slope and the b is our y-intercept. Now the only difference between the slope-intercept and the direct variation formula is the idea of this y-intercept. If you'll notice here, our direct variation formula is y is equal to kx. Well, k is what we call a constant of proportionality, or our proportionality constant. Okay, so it's the number I'm going to multiply x by, and what you find out based on this definition, whatever I multiply x by, I'm also multiplying y by that also, because they're going to change proportionally. Okay, so the value of y, whatever it is, which is our dependent value, is going to change according to what I do to this x value. So take, for example, if I have this value here be 5, the y value on it to be a 10, and this x value to be a 5, whatever this k value is going to be, I'm going to multiply this 5 by that k in order to get this 10. So k would have to be 2. But if I were to take this k and change it to like 3, then my y value is going to change. So if x is 5, I'm now going to multiply it by 3, and this y is going to change to a 15. So it changes proportionally. So this one changed by multiplying it by 3, so this value here is going to be basically 3 times that value. It's going to change according to that proportional value, that constant of proportionality. So the big difference between direct variation and slope and y-intercept form is in direct variation, your y-intercept is always going to be 0. Okay, so there's a couple of things that you'll notice when we look at equations is if you have any plus or minus, then there's not going to be a direct variation probability. We're not going to have that. You're not going to be able to do a direct variation. Okay, so let's see if you can determine that. So here we've got two examples, and all I want you to do here is tell me which one is not an example of a direct variation. Well, if you look at the three equations that we have, you'll notice D over here, it only has a slope, does not have a y-intercept. Okay, so that means our y-intercept would be 0. So this one is a direct variation equation. Y is equal to 4x. It is also a direct variation. Y is equal to 5/16 x. It's also a direct variation. But you'll notice A here's got a plus 1. Well, this plus 1 rules this one out. It is not an example of a direct variation problem. Okay, so on number 2, let's do this one. This one's got kind of some interesting things. It says, which equation is not an example of a direct variation? So again, this one is good because we know that whatever value is in front of x, there's a y-intercept of 0 because I don't have a plus or minus. So the value here in front of x should be 1. So y is equal to 1x is perfectly fine. If you look at C, y is equal to 1/2 x. Perfectly fine because the y-intercept is 0. We don't have anything there, a plus or minus. Okay, but when you look at B and you look at D, we got some interesting things here. So let's first look at B. Okay, so in all of our equations, we want the formula to be y is equal to kx. Okay, so what I really want to do is I need to move this x to be on the other side of this y, because you'll notice the y is here on the left, the x is on the right. So I need to move this 2x over to be with that 0. And how do I do that? We add its opposite. So if I subtract 2x from both sides, I end up with 3y is equal to negative 2x plus 0. Well, that plus 0 is just fine. It's our y-intercept. Matter of fact, you could not even put it and it would be okay. Okay, so we've got 3y is equal to negative 2x. If I divide both sides by 3, I end up with y is equal to negative 2/3 x. So this one here, again, has a y-intercept of 0. But if you look at D, this one is kind of an interesting one. If I move this 5x over to be with that 30, so if I were to move this 5x, I'm going to subtract 5x, and I'm going to subtract 5x over here. So I end up with 6y is equal to negative 5x plus 30. No, that 30 went outside, sorry. So 6y is equal to negative 5x plus 30. Okay, so automatically you see that there's a plus here. So that means there's going to be a y-intercept. Okay, a y-intercept of something other than 0. So that rules this one out. So D is the one that is not an example of direct variation. So let's see if we can actually work a couple of direct variation problems. Okay, so your direct variation problems are always going to look in this format for the most part. Okay, if it's a direct problem. We'll look at one in just a second that's not quite like this, but you'll understand how it works. It says, suppose y varies directly as x. If x equals 5 when y is equal to 12, what is x when y is 30? Well, all we have to do to solve one of these is set up a proportion. And our proportion is going to look like y over x is equal to y over x. Okay, we always want to put it as y over x because that's our delta y divided by delta x. It's kind of the same format that we're used to. So we look at our values and we see that y is equal to 12. So I'm going to put a 12 over my x value of 5. So you're always going to know one full ratio, and we're going to be looking for the other side. So in this side, since we did y over x, we're going to do the same thing on the other side. So y is 30, and I'm looking for x. So now in order to solve this, we'll cross multiply and divide. So we take our x times 12, and we end up with 12x equals, and we take our 5 times 30, which gives us 150. Okay, so we divide both sides by 12. So you'd take your calculator and you would do 150 divided by 12, and you end up with 12.5 for my answer. So when x is 5, y is 12. If y is 30, what is x? X is going to be 12.5. And now we've got one more question on this particular page that I want you to look at because it's kind of an application problem. Okay? And this is where you've got to kind of remember that your y value is your dependent value and your x value is your independent. It says Heather's weekly pay is directly proportional to the number of hours she works at the record store. Her pay is $174 for 24 hours of work. Find the amount of pay for 40 hours of work. Well, this hours worked is going to be like our x because it is our independent value. It's what our salary is calculated based on. So it says that for 24 hours of work, we get $174. So this is our x and this is our y. So we would set this up as 174 over 24 is equal to, now this 40 is our x, so it's going to go on bottom with the x. And then I'm looking for y. Now there's really no magic of y over x and y over x. As long as however you set this first ratio up, you set the second ratio up the same way, it'll work. So if I did, instead of y over x is equal to y over x, what if I did x over y is equal to x over y? Would that work? Yes, it would. Okay, so kind of remember that because you're not always going to have an x and a y. Okay, on a couple of the questions, or one of the questions for sure that you'll have on your assignment, it doesn't have an x and a y. It has an a and a b. So as long as you set up the second ratio exactly the way you set up the first ratio, then the proportion will work. So in this one right here, we're going to take our 24 and our y, we're going to multiply that together to get 24y equals. And then we're going to take our 174 and our 40, and we're going to multiply that together. So you would take your calculator and you'd multiply that, and you would end up with 6,960. Then you're going to divide both sides by 24, and you'd find out that y is equal to, okay, $290. Okay, which is what we're looking for. For 40 hours of work, you'll make $290. So what I'd like for you to do is exactly like what we've been doing. Okay, you're going to follow this link right here, either in Classroom or copy and paste it into, or just type it down and type it into your Google window, and it'll pull up a form for you. Now today we're going to be working 5 questions. Okay, I've given you 5 direct variation questions. Now what I need for you to do, and I need you to listen carefully, the type of answer that you're going to put into the form is just a number value. Okay, so you will type in, you will set up the problem, you will solve the problem, you will come up with an answer. That answer is what you're going to put into the form. Now each of these answers are going to come out nice. So if you get something really squirrely, then you probably did something wrong. Okay, go back and check it, because all the answers that I came up with are nice, pretty numbers. Okay, so until next time, have a good day.